are you, my friends? This is a continuation of the series Basic Math Terms related to terms in pre-calculus course. The videos will be part 19, inverse and exponential functions, and then part 20 will be logarithmic functions, part 21 will be angles and coterminal angles, and so on. Now, there are two important notes here. Note number one, videos on algebra terms. There were parts from 1 to 18, and videos on calculus 1 terms are coming soon. So this is basic math terms, part 19 from pre-calculus course, lectures 1, 2, and 3. One-to-one functions, horizontal line test. There are two important notes about inverse function, exponential function, the base, horizontal asymptote, natural exponential function, increasing and decreasing according to the base. So one-to-one function, a function is one-to-one. See the word one-to-one, x and y. Every value in the domain has exactly one different image. Every x here, every x value in the domain has exactly one y, one different y. So this one is not one-to-one here. This is a function, but not one-to-one, because 2 and 3 here, they have the same image, 7. But here this is one-to-one. 1 goes to 5, 3 goes to 6, 2 goes to 7, 4 goes to 8. So this is a function and one-to-one. Now, horizontal line test we can use if we have a graph of a function and we need to know if this function is one-to-one. If it is one-to-one, it has an inverse. If it is not one-to-one, there is no inverse. So we just draw a horizontal line here. You see, this is the line here. If it cuts in 2 points or more, then this graph is not one-to-one. So like here, not one-to-one, because there are 2 points here. 2 values for the x, they have the same image. So we call this horizontal line test. Now, very important notes in the inverse, you can see here, we call these cancellation properties. F circle F inverse of x, which means f of F inverse of x is x. This is an example here. Also, F inverse circle F, this is the composition, or F inverse of F of x is always x. Now, note number 2 will be the domain of the F is the range of the inverse, and the range of the F is the domain of the inverse. Definition of exponential function. Exponential function has the form f of x is equal a to the power x. A is a constant, it's a number. The conditions on a are very important. A should be greater than 0. That means positive, and a cannot be 1. X is any real number. That's why we can say the domain of the exponential function, all real numbers from minus infinity to plus infinity. Be careful about the base. A greater than 0. So it can be half, 1 over 3, 1 over 7, 1 over pi, and not equal to 1. Here we see more details about the base. Base cannot be negative, remember. We mentioned that. A greater than 0, a cannot be 1. So if you go in details here for the base, you can go from 0 to 1. There are infinity of numbers there from 0 to 1. All the functions here, if you take this base, these are decreasing functions. If you take a greater than 1, that means above 1 until infinity. Take any number there, like 2, 2.1, 1.6, 1.5, 1.2, 1.01. E, there's a number E here, irrational number, 2.718. And there is a pi, 3.1416. These two numbers are irrational numbers. And you can take 3, 3 over 2, 4, 7 over 5, any number there greater than 1, the function will be increasing. Now, this is a caution only. You have to be careful. Don't be confused with the -1 in the inverse when you write inverse and the -1 in the negative exponent. They are not the same. So when we say here 5 to the power -1, this is 1 over 5. This is from algebra. 3 to the power -2, 1 over 3 squared, 1 over 9. Now, this is a symbol here. This is the inverse of the function. We cannot say f to the power -1 because this is not equal to 1 over f of x. We say f inverse here. Look here. We say f inverse of x not equal to 1 over f of x. This is the inverse. And this is the reciprocal. That's not the same here. Okay, just be careful. Natural exponential function. We know what is exponential function. What is a natural one? Natural one, we have the base only e. We have mentioned before, the base can be any number positive, not equal to 1. So the base can be 2, can be 1.5, can be 3, can be 7, can be e or pi. If it is only e, we call it, sorry, back again in the natural. So the natural, only the base is e. This is e 2.718. And the domain is all real numbers, and the range will be open from 0 to infinity like other exponential functions. Now, the increasing, where we have the base a greater than 1. Any base greater than 1, even starting any number 1.001 will be increasing. And these are the information you need for this graph. It will pass through 0 and 1. If you put here x equals 0, it will be 1. So this is increasing. The decreasing one, when the base between 0 and 1, any number, 3 over 4, 1 over 2, 7 over 8, any number between 0 and 1, the function, the exponential will be decreasing. And the range here from 0 to infinity without shifting. If you shift the graph, the range will change, but the domain will stay the same, or real numbers from -infinity to +infinity. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.